Cool, and we haven't even gotten to the discussion yet. So I've just put up some random points that may or may not be interesting on 4 slides to encourage conversation. So we'll put these up one at a time and feel free to share your thoughts or unrelated thoughts. So with regards to the models, I think we can talk about, some of this is obvious, which physical components of the atmosphere system and above we want to interface with JEDI, what that might look like if there's ability to share model interfaces, how we might do coupling across different components like thermosphere, ionosphere coupling was talked already about, but there's different options of how to do this, and control over the execution. Any takers?
So yeah, the interesting question I have here for this community is that, you know, I know at the Navy, what we are taking the standpoint of, we have an ionospheric model, and we're going to do data assimilation on the ionospheric model. We have a thermospheric model. We're doing data assimilation on the thermospheric model, and then we're going to combine those through coupling. I know there's people that are using the WACOM-X model. Now, WACOM-X has both the thermosphere and the ionosphere together, so you don't have to deal with that problem. You guys can already jump into the thermospheric ionospheric coupled system. You're running with that, and I think it's I think to some extent that there's a lot of interesting things that you're going to run into before we do if you start going in this direction. There's supposed to be a question there. I forgot it.
Maybe in reference to the second bullet.
Yeah.
I think that, yeah, you have an example there. That example is the simplest one where both these models actually use the same core, the same grid, the same everything. So GSNF and GFS are no different from the perspective of an interface. So the thing is that, you know, given that you already have different interfaces for MPAS, FV3, LFRIC, so you're most likely going to have different interfaces for whatever other space model varieties you may have, no?
Sorry, are you sorry, I want to make sure I understand. So are you suggesting that like the interface for FE3 JEDI might be useful for the whole atmosphere models that we're describing?
I'm just saying, you're asking whether you can handle multiple models with a single interface, yeah?
Yes.
And the answer is no, right? Because at least not now, because you already don't do that.
Well,
Because you have LFRIC, you have, you know,
we
FE3.
sort of do with FE3 JEDI and GEOS.
FE3
JEDI and GFS.
It's the same. I
It's
mean,
the same die-core.
there's no
So what I'm
difference.
asking, okay, so let me rephrase the question. Are there groups of people in this room who are using models that are so closely related that they could be considered nearly the same
Yeah, the
and could
same-
work
yeah,
together
yeah.
to
Models
develop
with the
a
same grid.
single
Right,
JEDI?
models on the same grid would be able to share the same interface most likely, yeah?
Same grid, probably would need the same die-core so that you're calling forecasts, you know, propagating forecasts in a similar way. I don't know, that may not be necessary. Definitely the same grid.
Well, an obvious example might be the extended these yeah a single interface, you said? Yeah, so that's one example where you might have, if you have two models using the same grid and they do have similar state variables, you might be able to, I don't know, reuse parts of the model interface. I don't know if it's going to be the same interface, but variations on a feature.
Yeah.
Dave, this is what you're kind of trying to do with the PyRI and SAMI, right? And I think at least the grids, I think, but the model stepping, I think you can maybe include some, yeah. But I think that's what that plan is.
But that's just within ourselves. This is
True.
Every single person out here that will have a different group.
Okay, great.
I
Sounds
would
like we've
just
answered that one.
comment back to Dave's point about, you know, thermosphere and ionosphere. at least for WacomX, we have everything coupled together, so it's, would be, I'm not really sure how we would separate them. It would be, wouldn't make sense. I think maybe for other groups, I could see you would want to do it differently, which would be Navy and WAM IPE, they'll be separate. Maybe I have some memory of we had this discussion a while back of like, you might be doing the data simulation at different cadences, and that could be an advantage of, having them separate. For WacomX, we could come up with a way you could maybe do that, but I think we would want a single sort of interface. And I think to that point, if you're doing like the Navy approach, the grids are completely different for thermosphere and ionosphere. So I don't know technically if there's any reason you would want it to be in one thing, because I don't know if you can do two grids within the same interface.
Not easily today. So I am, just to make sure I'm stating myself clearly, I am definitely not recommending that you split an existing coupled model. I am more trying to, have this discussion because one of the outcomes is JEDI today isn't ready to couple to assimilation systems. It's work in progress, but on what timescale are we trying to have this ready for use by this community, for example?
Yeah, and also to what extent can you use generic components? So for example, one question that came up when Francois and I were talking about this discussion was, let's say you have, so UFO, you have a multiple observation operators, and not every one is relevant to every model. Like there are ocean observation operators that aren't relevant if you're just doing an atmospheric model. So are there any examples now, for example, if somebody came up with a B matrix for the ionosphere, could that be in SABRE much the same way that that UFO is done, is that some models would be able to use it and other models would not? And if that's the case, could you use an ionospheric B matrix with a coupled thermosphere ionosphere model? And so that might be another reason to split it up if it's easily done. If the model is already pretty well integrated, then maybe it's not worth it.
I assume we're talking about research, because in operational world, you gotta think about what you want to do, right? You want to think about, again, in my talk, we talk about what phenomena we want to look at, what capability we want to build. Then from that, think about what ionosphere model you want to have, what neutral atmosphere model you want to have in order to create those. For example, you want gravity wave, you want small feature of ionosphere, you want ionosphere to be small enough, you want thermosphere model to capture the waves that we need. Then, and again, how do we run a model with the drivers, right? So I think we're going a little bit too broad in terms of getting somewhere. So it really, I think it's hard to discuss this point when we don't know what we're trying to target. We can, if our goal is just to come up with something so that, for example, TI-AGCM can use it, then that's clear. But obviously, ionosphere model is different structure, different model, different structures. Do we want to target ionosphere model has ionosphere structure, like magnetic field structures, and what magnetic field structures work for that? Then we probably can get somewhere. And then think about thermosphere is different, right? We're talking about whole atmosphere model. Then we talk about a V3 WAM development, which is still up in the air right now. So I guess we have to have whole atmosphere model to put a JEDI for, I don't know, but maybe not. Maybe we can just try out some thermosphere model by itself. So I think gotta have a little bit more specific topic so that we don't go everywhere, because everybody has their model, I think. I don't know if it's helping, but I just think we're going in a circle and there are 10 models going through my brain. I don't know what we're talking about. So maybe somehow we gotta make it a little bit more targeted. For example, you guys are working with Navy's model. Maybe we go with that route and see how we can have because you guys are actually putting money to do job, right? So we're gonna take whatever you are building and see how you fit into what we need, maybe. And maybe Tom's project is building something. So what do you have in your mind that your development will help the rest of us? I think that might be a direction we should go. I'm just trying to figure out where we're going. That I have no plan at this point.
Wanted to respond to that a little bit. I think the goal here is to, for us developers of Jedi to know what can be coming in the future. Drives the design of the code. And if we don't know what's out there and we don't know this domain, right? Then we don't know, and we might be limiting ourselves in the design choices, which is why we're kind of going broad and want to know what are all the possibilities or most of the possibilities of applications that would be coming into Jedi or could be coming into Jedi. But I agree with you. Of course, we can't do everything all at once. And I think the goal here is sort of to see what are the design possibilities. Yes. We already see that these models are substantially different from the models that we've dealt with. I was saying you can just assume everything's on the sphere or part of the sphere and vertical columns, and that's not.
We'll get Ricardo, but I think that's a good transition to your next slide. Go ahead. Go to the next one, Francois. You
would
want to
it-
go to the next
would
slide
it be useful to,
just to get through this?
Would it-
Some of this.
would it be useful for somebody in the space where the community or somebody from CCMC or a place like that to come up with a survey of the models and the grids that these models have and, separate them in categories so that at least the Jedi group has some knowledge of what's out there.
Yeah, and even more useful if we know likelihood of funding associated with each model.
Yeah, so
But
I think,
absolutely, yes.
but I think this relates to some of the things where the discussion is headed in terms of how we work these models in. And one of the biggest differences with regard to other atmospheric models is the grids.
But I think we had one unasked question.
Yeah, and I'm not even sure how to ask this question. It's going to be vaguely about coupling. And I'll selfishly talk about WAM in this context, that if we're talking about FV3 WAM and it fits into the FV3 Jedi that already exists, if we're just extending the model top and therefore the interface is already valid for us. But I'm envisioning the scenario where if we build this Jedi that interfaces with IPE, and then we have a coupling component to that, because you can't update one and not update the other and expect the two regimes to integrate forward in time in a balanced manner. Would those coupling interfaces depend on those individual model components? If we were to then replace IPE or replace FV3 WAM with an MPAS-based WAM or something like that, would those coupling interfaces then need to be redeveloped, or is that a part of developing that individual interface itself?
Like if you can pass the microphone to your right.
I was hoping Unique will take this one. So we're developing some, as Francois mentioned, that's a work in progress, some generic coupling capabilities, which can go. We have done the HFX for coupled models where you basically have an interface to one model. And in our case, it was an atmospheric model, FE3. And we had a separate Jedi interface to the ocean model. And that generic coupling allowed you to, without writing, more than 5 lines of code, basically run an HFX or an observer, compute the equivalent of observations from the model using the ocean component and the atmospheric component and using the sort of generic coupling mechanism. So we have in the plans going, further with that, doing coupled covariances. And there will be places where it's going to be hard to do it in a generic way for everything. Like one example would be if you want to run a coupled model, you might want to write a code that actually taps into the coupled model and then puts together the states for one component and the other. But there's definitely and existing development and plans to expand this to do the coupling in a generic way where it's possible. And so, yeah, if you had the two interfaces to two different model that you wanted to couple, you probably would be able to do a lot of things in this generic way. That being said, if you have a new model that you're coming in and it's coupled and you're going to be running writing the new interface anyway, I would probably just write the interface for the full coupled model.
Is that process easier done if you're doing like I think there's a difference between running Jedi separately and if you're actually using like the Nuopsy cap from within the model to kind of run Jedi in an online manner. Does that simplify the process at all, or is that completely unrelated?
So when I think about running the model in Jedi, basically there's this classes and methods, but basically there's like one method or function, however you want to call it. And it says, I want to propagate state in time from time T1 to time T2. And at most of the level of Jedi, it doesn't care how you do it. So however the model is implemented inside it, it's agnostic to that.
Just ask a question related to this. So that means if your model is already doing, so similar to what you just said, so if your model is already doing the coupling itself, so you have like a ocean model, right? Atmosphere and ocean model, and that coupling is already being handled by SMF or Nuopsy or whatever it is. That means you can't enable the present FV3, say, interface, in this case, to handle that one long state, which will be a mixture of fields in two different grids. You know, I mean, that would be an alternative to building couplings through OOPS and everything else in the Jedi. So I don't know if that's possible.
Yeah, so that's where you'd have to have two model interfaces basically and do the coupling with that.
How is it done in the extended version of Geos? How is the ionosphere coupled in? Is that done on the FV3?
Well,
Okay.
Yeah, I mean, for us, we only couple one way from WIM to IPE, so it's kind of a very simplified. Like Sue mentioned, we can't assimilate ionosphere data and have it propagate to the thermosphere right now. So that's a limitation of our modeling suite as it stands.
Yeah, but for the example of sort of FE3 WAM and Geos FV3, the adding in the ionospheric component might break the shared model interface there. I guess depends how it's done, but
So I can talk to the what the Navy's doing in that respect is that we too are at the standpoint right now where our thermospheric model is driving our ionospheric model. We did have it Nuopsy coupled, and we were going to do some two-way coupling, but that is a huge step for anyone that's ever tried to do two-way coupling. It's a huge step forward, and we just sort of stopped it because we were getting enough with the one-way coupling. But with that said, the thermospheric model did need to have ionospheric information because of those heating rates. So what we ended up doing in our thermospheric models, we ended up putting IRI in there. And so the IRI was giving you the heating rates that you were getting, so that's where our thermospheric model was running off of. But that was not, it's not right. It should be running off of the ionosphere that we had over there. But since it's a secondary outcome, it was close. It seems like it's close enough that we can get away with it for right now. But yeah, that's what we're running to.
So I just want to make a few comments about the coupled stuff. You can write a Jedi interface to a coupled model. You can write a Jedi interface to an atmospheric model, an ocean model, and a per atmosphere model. So there's some technical implications that people are focused on here, but scientifically it opens, it's different. Like it's not the same. There are also scientific choices behind that. It's not just a purely technical implementation choice. And but I think it's way too early to know what's the best way to do this scientifically. So to investigate that, And to do that science to decide what's the best way, we'll probably need to implement both. So in a way, I'd say it's, you know, we can't decide now because we don't know the science. We don't know what's scientifically is going to be the best in long term. And to do the science, we need, you know, we need the flexibility of trying both. I don't think there's any other way.
Yeah, and that's why our project has 5 years of doing that coupling work. I mean, you're totally right. We can't answer the question right now. At least I can't with my knowledge of what the literature has said, but maybe someone out there knows. But I think is we've got a lot of work to do, and it'll be interesting. And
We don't even know for the atmosphere ocean coupling, which we've been doing for longer. We don't know what's the best way to do it. So for coupling with the ionosphere and all that, there's a lot of science to be done. And you know, we're building the system to enable all that science. I think that's what we should focus on. And you know, there was a comment about for an operational implementation, you need to know what you want to implement, but you need that upstream science to decide what you're going to implement in your operational system. So I think some of these discussions are a little bit premature in you know, deciding how you want to implement that.
Well, one of the challenges there is sort of about this slide too, of if we are going to do the coupling with JEDI, then what's the outlook for getting a geomagnetic grid into Atlas?
Yeah, I was going to request that we maybe keep going through unless if,
To address the comment about the science
Yeah.
that needs to be done, I totally agree. And to give you the lay of the land at NASA, which is the funder, biggest funder in space weather right now, they've also, in addition to the SWORD Center that I'm leading here at CU for this sort of more operationally focused, DA-focused investigations, they've also funded what they call drive centers, one of which is called the Center for Geomagnetic Storms at Johns Hopkins. And they're doing a lot of this basic research into coupling atmospheric and ionospheric models and magnetospheric models. So they do have an effort ongoing that maybe hopefully is addressing this a little bit. I see some hand waggling, which I agree is they may not be aware that this is maybe where they could be focused more productively to serve the rest of the operational community. They might be going down other scientific rabbit holes, but it's worth talking to them and bringing that up, that they have more funding actually than the space weather centers as well. So they may be the ones that we can lean on a little bit for this kind of research to figure out what is the best way to couple the ionosphere to the thermosphere before we try to charge down some operational route.
Next, we should go. There's a question online from Valerie.
Yeah, basically, I just would like to put a more practical first step. So I think we have actually issue how to extend atmospheric data simulation to the thermosphere. First of all, we need rapid data analysis. And my question is for JEDI, what's the shortest data simulation window you already use and show how to improve diurnal cycle representation using the data in the atmosphere? This is the first question. The second one, this is basically our favorite gravity waves. If you look at the representation of current meteorological analysis and put the kinetic energy spectra, global kinetic energy spectra, so you can see that starting from the global spectral wave number 70, you have drop-off kinetic energy, dramatic. So we need also to think about how we can basically do data simulation properly, not basically degrading mesoscale scale. So we need to think for thermosphere about mesoscale data simulation. So this was two topics probably very important if we go to resolution from current WAM-IP 200 kilometers to FF3 125 kilometers and start to match the operational analysis in the low atmosphere. This is two bullets basically. Rapid data simulation and representation of gravity waves in the data simulation. Any thoughts on this?
I don't know how to answer that. We're trying, so if I understand your question correctly, it was about the time scale and how short in a simulation window we can do. So you can you know, so from the code point of view, you can make it as short as you want. There's no limitation there in the code. Then there's, you know, the science question, and we're developing different things to do what we call continuous DA, where you know, the window could be evolving like 10 minutes at a time or something like that, and then running continuously. There is, on the other hand, I think for some of the questions you were asking, there's experience at ECMWF as showing that having a longer window is better to represent some of these things, like a diurnal cycle. But you could combine the two and have a long window that slowly moves forward, and kind of, you know, like a train that progresses, and so the windows kind of overlap almost completely and just move forward by one time step at a time if you want. There's a lot of things like that that I've been very interested in for a long time. So the system allows all that, and if somebody has millions of dollars in computing resources to give me, I'm happy to try these things, but at the moment we don't have resources to do it.
So you basically suggesting to use 4D-var, 4D-NVAR, something like this?
I think for some of, if you want to capture the, you know, diurnal cycle, things like that, you need something 4D. You can't capture something that has a time dimension in 3D. That's, you know, going to be blocked there in your representation of whether it's a diurnal cycle or something else, something that has a time dimension. I mean, yeah, 4D-var is obviously the best, you know, the best we know today to do 4D data simulation. And I think there's potential now with AI to extend on that and blend 4D-var with some AI machine learning methodologies, which that's how I would go.
So basically my question is another question is basically we need for this application to get and test representation diurnal cycle of background error covariances. And to propagate background error covariances, perhaps we need, for best implementation and successful results, we need probably something like tangent linear model of and propagate with covariances consistent, not probably ensemble data simulation.
Yeah,
what's your thought on this?
Well, yeah, I think you're probably right. At the same time, you know, your tangent linear models, they don't need to be exact. They can be approximate, and that's good enough. That's also something ECMWF has shown for a long time, but you can have an approximate tangent linear model.
Yeah, basically what we would like to do, we would like to bring on board the good assimilation of tides, global scale waves, and this is adjust-trophic component of emotion. So we need adjust-trophic covariances modeling. Definitely, because this is quite strong variation, and this is dominant variation in the thermosphere.
But we do have another DA discussion scheduled for tomorrow, so maybe we could pick this up again then. We have about 5 minutes left in this session. We had one more topic that we can just bring up, and it's sort of you can think about overnight, and maybe we can talk about it tomorrow. But before we leave this topic, I just wanted to ask. Let's say we require the ionospheric models to do the interpolation from the geomagnetic grid to lat long grid for the purpose of assimilation. If that was the case, does JEDI even need to know about the geomagnetic grid? If you pass your geovals in terms of lat long, UFO, then is there anything, if the model handles that interpolation, is there anything that JEDI needs to do?
So let me answer by a question, right? If you're only asking about the OBS, then the answer is the OBS system doesn't know about the grid anyway. If you're asking about the whole JEDI system, which includes not just the geovals, but it includes the covariances and it includes linear algebra and things like this, which have generic implementations or will soon, then yes, it does matter. So if you are taking your model on its magnetic field conforming grid and interpolating to a lat long grid anytime you interact with JEDI, such that JEDI only ever sees a lat long grid, then we're done, we're good. We're on the left side of that previous plot. If you want to be working natively without those back and forth interpolations, say because you're worried about degrading your accuracy, then we do need to worry about this stuff. But I guess well, maybe we should just wrap this up. Yeah.
Bring up the last topic. I think that largely answers the question. At least it's a place to start, and maybe in the future we'll have capabilities in Atlas and or Sabre to deal with more general grids. But for now, if the interpolation is done by the model, that might be a good way to start. And then just the last 5 minutes, this overlaps with tomorrow's discussion, but go ahead to your last slide. Any other comments on? Go ahead.
Can I ask,
Yeah.
so I know that Dave at NRL is very interested in using the conforming magnetic field following grid. I don't know what to call it, geomagnetic, let's call it that. Amongst the other ionosphere models, is there a strong opinion as to using such a grid versus interpolating to lat long?
I guess my question to Dave would be, is there a science reason that you're concerned about that, or is it a technical thing?
No, it's completely science.
Yeah.
It's because of the correlations.
Right.
That's why we want to do it.
Yeah, I think that makes sense. I'll agree with him.
All right.
So one thing that I wanted to reach back to is what Sue and Ricardo was talking about, like, you know, there's a lot of different models here, and there's and it's too big of a problem. How do we get this problem a little bit easier? And one way that might be a way to deal with this is, and I hate to make more meetings or something like that, is to have like a working group which would have like a representative from the different models that, you know, just maybe an email chain or something like that when we start making these decisions in JEDI, because we're making the decisions right now. And so that, you know, at least it's passing over your desks, but maybe, you know, get some sort of group to say, okay, you know, at some point in time, my model might go into JEDI. I'm kind of have an interest in this. I have an opinion on this, and they can affect it, but maybe that could be an outcome to make it so that it's not every single ionospheric and model that's out there. But,
Sure, yeah. In fact, the okay, well, shall we wrap this up here?
Yeah, I think we only have, we can, yeah, well, we're pretty much, we have time for one more comment if somebody wants to have a last word on this. Well, it won't be the last word because we have other discussions for the next day, for the afternoon and tomorrow, but.
All right, well, thanks all for the good discussion.
All right, yeah, thank you.
Okay, we are going to have our break, but before you go grab your coffee, we are going to have a group photo outside, and one of our IT guys actually agrees to take a photo for us. Very nice. They give us extra support. And also, I think Leslie has an announcement for the dinner as well.
Okay, dinner is settled for this evening at 6:30 at Chautauqua Dining Hall. I have a reservation for 13, but it looks like it might be 12. So if there's one